Okay, so we're going to be talking about the periodic table. And here's your big, nice picture periodic table. Everybody's got one. This is the one that the state of North Carolina gives you. And when you take your EOG test in a year, this will be the one thing they give you with your scratch paper and pencils. They'll give you this actual periodic table. And we're going to kind of talk through it and talk about some things. So, go ahead and get this up. Now, periodic table. It's a chart that kind of organizes the information about elements according to their atomic mass and properties. Everything, this is kind of like the recipes, the ingredients of the universe. Everything in the universe is made out of these atoms, no matter what it is. And there's different things, and we'll go to that in more detail. Now, a period is actually a horizontal row. So you got a horizontal row right here. The horizontal row, that's a period. You go across. Now, going up and down, that's called a column. Or the column is called a period, it's called a group or a family. And each one of these has, and you can see the numbers on here, 1, 2, 3, 4. Those are different groups. So if I said, name me an element from group 8. So you would go to group 8 and you could name any of these. So iron would be in group 8. Now the crazy thing about this is that on the periodic table, we can actually tell the reactivities of certain elements. And see, in a column, everything has similar properties. So iron would be similar to ruthenium, to osmium, and hafnium. Now I know y'all have heard of iron. And you probably never heard of ruthenium or osmium or hafnium, but they all are similar to iron. Okay, have similar chemical properties. Okay, you have these other ones over here: lithium, sodium, potassium. They all have similar properties. We'll talk about them in a few minutes. So that's periods or rows. Columns are the groups, families. Called families. They have similar properties. You better know that. They ask about 1,500 questions about that. And what they'll do is they'll give you, okay, which element has a similar property to lithium. So you would find lithium on your periodic table, and then you would go and see which of the choices is on that column. Okay, our atomic symbol, and I'm going to go back to this right here. So the atomic symbol, well, I ain't going back. Oh, I got to click it on. The atomic symbol is, of course, the letter. Now, you notice some letters, oxygen's O, fluorine's F, nitrogen's N, carbon's C. That's easy. But sometimes it's not always like that. For instance, let's find gold. Gold is right here, number 79. It is AU. It's not actually G. It's AU because a lot of times they use the Latin form or the translation of that element in another language, okay? Copper is Cu, but there's no U in copper. Ag is silver, but there's no A or G in the word silver. Sodium, talk about sodium that's in your food. It's like the salt. That's Na, okay? Potassium is a capital K, not a P, okay? So you got to know that. The whole number is, of course, your atomic number. That tells you how many protons. So if I say, what is the how many protons are in sulfur? Well, you find sulfur on the periodic table. Ooh, sulfur, there's 16 protons. And if it has 16 protons, for 8th grade purposes, we have 16 electrons because we're not working with ions and that kind of stuff. You'll get that later in high school and college. Okay. Now, it gives you the word, what the actual element is, and it also gives you a mass. The mass is actually the sum of the protons and neutrons. So that's why I told you in the last section that if you wanted to find the number of neutrons, you would actually subtract. So if I took 32, round it to the nearest whole number, 32 minus 16, then I would get 16 neutrons. Okay, I got 19 minus 9, that gives me 10 neutrons for fluorine. 16 minus 8, that's 8 neutrons for oxygen. So that's how you figure out. You gotta do a little bit of math there. Not a whole lot, but a little bit. Now we got different categories here. You'll notice there is a staircase. This staircase is actually called, separates the metals and the non-metals. All the non-metals are on the right-hand side of the staircase. These are all non-metals. You notice there's not a lot of them. But on the left side of where everything else is, that's the metals. So there's more different metals than there are non-metals. But technically, if we counted all the atoms in the universe, there's actually more of these around than there is these. Okay? Now, you got non-metals. You got metals to the left, non-metals to the right. Now, along these steps, you have what we call our metalloids: silicon, germanium, arsenic, antimony, tellurium, polonium, bismuth, astatine. These are all ones that sometimes act like metals and sometimes they don't. Silicon's a perfect example they like to use a lot because silicon is what's in microchips for computers and phones and that kind of stuff. Because they can let electricity and sometimes they don't. I mean, you want your phone to be working, but you don't want it working when it's inside your pocket because it'll burn up in your pocket. You don't want that happening. Okay, so let's go through the different families. Okay, our first family over here on the left, we got the alkali metals. Now the alkali metals, they are very, very reactive. They're like the crazy. that crazy guys, the crazy guys that we got in eighth grade, y'all know who they are, the crazy ones. They hit water, they explode. And as you go down the chart, they get more explosive. Like if I take some sodium, pure sodium, and throw it in some water, it's going to give me a little pop. But if I put some rubidium in the water, it's going to have a big explosion. Now hydrogen's over here. It should actually, a lot of times, a lot of the periodic tables, they kind of put it over here up in the air by itself because it's reactive, but it's not really, it's a gas. It's kind of its own little thing. The second column we call the alkaline earth metals. The alkaline earth metals are used a lot in fireworks. Okay, calcium, that's what's in your milk. It makes your bones strong. They're reactive, but they're not as crazy as these. These are ones that maybe be like a class clown. Whereas these are the crazy ones that if you look at them wrong, they might do something to you, But this group right here, they're more laid back than these. And as you go across, the metals get less and less reactive. Now from group 3 to group 12, this big section right here, these are called your transition metals. Now these are the metals that if I asked you to name a metal, you would name it. Iron, nickel, copper, zinc, silver, gold. What's some other ones? Titanium, you heard of titanium before. Zirconium, that's what's in the fake diamonds, cubic zirconium. Okay, so you've heard of some of these before. Some of these you hadn't heard, but that's all right. Okay, aluminum's a metal, even though it's close to that sidewalk, steps. You got lead, you've heard of lead, tin, those are still metals. Now, over here in group 17, this is what we call halogens, Halogen. Now the halogens are like the crazy girls. The crazy girls, because you ever know how the crazy girls always want to hook up with the crazy guys over here? Well, guess what? They like to do that. Now these are crazy too. They react. They can kill you. You inhale some fluorine, chlorine gas, bromine, they'll kill you. Okay. But the crazy thing, on this left side, as you went down, they got crazier and crazier and more reactive. Whereas on this side, they're already most reactive at the top, and as they go down lower, they get less reactive. And when I talk about reactive, I'm not just talking about them being explosive and blowing up in your face or killing you. I'm talking about they like to combine with other things. This group 17 loves to hook up with group 1. Okay, they just bad boys and bad girls like each other. I don't know why. That's just the way nature is. Okay, that's how that is. Now, this last column is group 18. They're called the noble gases. Now, noble means they're rich. A lot of rich people stuck up. Don't like to be around everybody else. That's what that's what I want you to think of. Noble gases are the rich, stuck up people. They don't want to mess with nobody. They don't react with anybody. They don't like to hook up with nobody. They're stuck off to themselves. Helium, neon, argon. You've heard of some of these before. Krypton, Superman, planet Superman is from. Okay, I guess that guy who created Superman looked at the periodic table to find a name for a planet, and he settled on Krypton. But the noble gases, like I said, they are they're the least reactive. So I know you see questions like that. They don't react with anything. Okay. Now down here at the bottom, you have what we call the lanthanides and actinides. We don't really deal with that too much in 8th grade. But what it is, if you notice right here, it skips from 57 to 72, 89 to 104. It's kind of like these two bottom lines actually go inside here and will make the table go out farther. It's kind of like when you're writing an essay and you're editing it after you've written it, and you look back at it 2 or 3 days later, and you take like an arrow where you want to write something in the margins and put it there after you get done with your final copy. When you get to your final copy, that's what this is kind of. They did all this. And by the way, the periodic table was invented by a guy named Dmitry Mendeleev, who was from Russia. He figured this out that every 7 or 8 elements, they actually were similar, and so he kind of put them in these columns. Now the periodic table didn't like this when he first started, but now they do. And like I said earlier, 92 uranium, which we talked about with nuclear energy, that's the last naturally occurring one. Everything else keeps going and made in a lab. Everything past 92 was made in a lab, and I want to say they go up to 118 now. And I think that's pretty much it, but I'm going to check to make sure if there's anything else I need to tell you. We talked about atomic symbols, atomic numbers, atomic mass, reactivity. Now metals, I will talk about some metals. Most elements are metals. They conduct heat and electricity. That's why we use those. I love my cast iron frying pan. I love it. Okay, heats up really quick. Electricity. Copper wiring is what we use in buildings. Okay. They're getting ready to stop me now here. I ain't got too much time. But malleable means it's moldable. Ductile means you can stretch the wires. Now mercury is the only one that is liquid metal, and bromine is the other liquid that's a non-metal. Okay, I pretty much think everything else we've gone through. They got countdown, because if I get more than 10 minutes, they got to charge me. So I got 8 seconds left, but I think I've pretty much talked about all these on the periodic table. Yeah, I did. Well, y'all have a good one. See you later.